otherwise, and hopefully it doesn't.
Okay, so we're live.
Wouldn't reset my biology.
So, hi everybody, welcome to the TSC meeting. Today's main topic is going to be presented by Jian about Lisp, host location protocol. But before we dive into that, let's go to the standing item on the community acknowledgements. And I see that there's a new item that was put up by David. You want to speak to that, David?
Yeah. Sorry, there's an echo. You can hear me?
Yes.
Oh, everyone should turn off their mics. These mics are going on. Or.
Okay. So, giving a shout out to, apologies if I say the name wrong, but Itzik Ashkenazi. He's a professor at the Technion Israel Institute of Technology. He pinged me several months ago to say that he was interested in having his students for a networking class contribute to an ONOS project, and I followed back up with him last week, and the students are diving into it right now. There's a link there to a Jira ticket, but they're working on a fault management feature, and he said the students are really, they got their environment set up and they're starting to dig into it now, so wanted to give him and his students a shout out. But then he also announced, or shared with me, that he's looking to deploy ONOS on a research network he has there as well. So just want to, both of those are great things, and just wanted to give him and his students a shout out. So thanks to them.
Yeah, that's awesome. Thanks, David.
And also, if I can add something, like he recently reached me out to contribute on the P4 project.
Oh, really?
Like this morning. Yes.
Okay.
Yeah.
That's cool.
Yeah.
It's always good to
Luca made the connection.
Oh, that's nice. Very cool. Yeah, it's nice to see enthusiasm like that. Okay, so I think with that we can pass the baton to Jian, and I think I'm gonna make you a presenter. Okay.
Okay.
So you're gonna have to share your presentation or your desktop.
Okay. Okay. Today I would like to give a talk on the Lisp protocol, like the locator identifier separation protocol. Oh, hold on. It's not. I need to share another.
I think you need to share the whole screen,
yes,
otherwise it's going to go through. Yeah.
Entire screen. Okay.
Perfect.
So today I would like to make a proposal for the Lisp controller for ONOS. So Lisp stands for Locator Identifier Separation Protocol. So this protocol was initiated by Cisco at first, and now it's a open protocol. So there are lots of RFC already available. So today, this is the agenda of today's talk. First of all, I will give a brief introduction of Lisp and some operations that Lisp does, and some open source projects are available in Lisp. And also, based on the state of art, I would like to propose a Lisp control plane for ONOS. And I will also show some sort of use cases if this kind of the Lisp control plane is available for ONOS. So, first of all, this is a brief introduction of Lisp. So, as you know, the existing IP address has two types of role. One role is the endpoint identifier, which uniquely differentiates a network host. And another role of IP address is a locator that is used for routing a certain packet to destination. And with coupled IP address role, somehow it's difficult to provide the host mobility, also the scalable routing. So for example, assume that we have two data centers, and if we want to move one virtual machine to another data center without changing the IP address, it's really difficult to make it up. And without changing the IP address, we also break up the network connection. So somehow, and in all cases, it would be good to preserve IP address, even if we move from one place to another place, and also make this networking enabled. And the second thing is, if you consider the multi-homing scenario, assuming that we have a provider independent IP address has been assigned to an enterprise network, and in that case, and assume that we engaged with two like service provider, like the service provider A and B, and they all use different IP address. Even in these cases, the provider independent IP address should be broadcasted to the all like service provider. So service provider should maintain whole bunch of IP address in their routing table. So routing table grows very fast with this scheme. And more services are not available by using this coupled IP address stuff. So, but in order to resolve this issue, the locator identifier separation protocol has been introduced. So we call this protocol as Lisp. And this protocol is type of a tunneling protocol, and it try to encapsulate. So in this with this protocol, we introduce two types of IP, and the one IP is just used for identification purpose, and another IP is used for locator purpose. And the identifier, so the IP that is used for identifier is encapsulated inside the locator IP address. So we also can regard this as an encapsulation like protocol as well. So IP encapsulation scheme, it decouples this host IP and the locator, and also it provides a way to dynamically map this ID to location. And so this is not disruptive like the changes to the existing router, because it just need to change the edge like device like edge switch and edge router in a network. So we do not need to require any changes to the end system or core in order to use Lisp. So I will bring up some like the terminology that are prevalently used in this Lisp. So here, the IP address that is assigned to a host, we call that endpoint identifier, and we call that EID for short. And another IP address is a routing locator, and that IP is typically assigned to a Lisp router that is typically located as an edge, like edge switch or edge router. And we also have some sort of mapping between this EID and RL, and we call that as EID RL mapping. And somewhere we need to maintain and manage this EID to RL mappings. So this is actually in the literature we regard this Lisp as a type of STM protocol because it decouples the control plane and data plane. So in the Lisp context, the data plane can be a set of hosts plus the Lisp like router, like what I'm showing here, like the Lisp IRT is a type of router, and the packet go through the entire like protocol stack. And since this is a tunneling like protocol, once the packet goes through the router, it will encapsulate the original packet, and it will put another like IP header outside of this packet. So the routing will be performed by looking up this outer like IP address. And in the destination, the Lisp router will encapsulate the packets, and they will send the original IP, the original packet to the destination host. And this kind of mapping, so it is a matter of how to program this kind of mapping between the EID and the RL. And in the control plane, there is a Lisp mapping system that provides a way to program this type of mapping. And there are already available a set of RFC which define this type of protocol, which define both data plane protocol as well as the control plane protocol. So it's open protocol. So I will give some examples how this Lisp like network works, the protocol works. Assume that we have two Lisp sites, and in each Lisp site we have one host. So the source is here, and you want to send one packet from source to destination. So in this case, first of all, we have a set of like routers. In this case, there's one IRT, the ITR, that is an ingress tunnel router, and this router is in charge of receiving the packet from the site, like from host, and they try to encapsulate the packet with its own IP address and send to the destination. And in the destination side, there's a ETR, that is an egress like tunnel router that is in charge of receive the packet from the core interface, and they try to decapsulate the packet and send the original packet to the destination by looking up the EID that has been specified in the packet header. So in the data plane, when we want to like send a packet to destination, assume that the original like a source IP or the original source is assigned the IPv6 IP address, and they want to send the packet to destination to D. And in this case, they first of all send the original IP like original packet to the XTR. XTR stands for ETR plus ITR, and this router will look up where this packet should be sent out by looking up the mappings between EID and the RLOC. And based on this map, the lookup, it will encapsulate the original packet with the this kind of routing, like its own like IP address, like 11.0.0.2, and also the destination locator would be 12.0.0.2. So this locator would be the IP address of the destination XTR. So the forwarding is pretty trivial because when you forward this packet, we always look into the outer packet header. So the inner packet header will never be looked up. So this forwarding is just as the same as the traditional routing. So once it arrives at destination, the ETR will decapsulate the packets and it get rid of the outer header, and it will recover the original the packets, and eventually it send the packet to the destination like this. So, but if you look at this, somehow we need to find a way to tell each XTR the mappings of the destination, like ETI and EID and XTR, the RLOC. So for that sense, somehow we need to have a certain sort of a control plane that's in charge of assign this EID and RLOC mapping to all XTR. So in the control plane, we also call it the control plane of Lisp as a mapping system. And there are two components in the mapping system. One is a map server. So map server is in charge of receiving the register request from ETR, or maybe it also received the map request via the mapping system, and either forward those kind of mapping request to the registered ETR, or reply that with the mapping that already exists registered this mapping system. And otherwise, map resolver. Map resolver, we typically receive a map request from the ITR, and if it has already mapped the data, then it will immediately return. Or if it doesn't, then it will ask the corresponding ETR to find the right mappings, and that ETR to send the mapping information to ITR. So typically, there are four types of Lisp control messages. The first one is a map register map control message. This message is used for register the register the EID RLOC mapping that is owned by the ETR actually. So ETR actually send its own mapping information to map server, and the map server should store that in its own storage. And once this process has been done, then map server will respond that with the map notify control message. And this type of acknowledge or successfully execution this EID prefix. Oh, sorry, is a typo. And another type of map a control message is a map request. Typically, a map request was sent by ITR. So when a certain packet has been received by ITR and there's no mapping information available for ITR, then it tries to ask the mapping system for this type of mapping. So this request, we call that map request, and they try to learn the EID RLOC mapping. And another map request is a solicit map request. In some cases, the host could be moved from one site to another site. In that case, it should announce that his location has been changed. So this kind of announcement can be realized by sending this solicit map request to the map system. And as a reply of this map request, there's a map reply message, and that typically sent by the ETR and to the ITR. And another type is a map server also can send a map reply to ITR if the EID RLOC mapping has been set as the proxy bit in this request has been set as true. So this is how this control message has been working. So at the beginning, ETR will send the map register message to the map server. If you look at this kind of package, so this is a map register request. It is verified by using the SHA-2 like cryptography like encapsulation like protocol. And it will send like this EID like prefix is under this like locator. So all like ETR supposed to send this the register message to the mapping system, and the mapping system will reply this by using map reply. So assume that in this case, assume that a packet would like so the source would like to send the packet to destination, and it send the original packet to the XTR, and assume that ITR has no mapping information to encapsulate this packet. Then it will ask the mapping system where this packet should be sent out. In that case, the mapping system will direct this request to the ETR. The destination ETR will, in charge of send its own like mapping information to the original like site, and the packet will be encapsulated and will eventually sent to the destination. This is the last case. This is the case if we use the proxy map reply. So in a previous scenario, it's a kind of how to say, it consumes some time because there are several like handshaking. Because first of all, you have to send like a request message to the mapping system. The mapping system also need to tell the ETR. The ETR should also send the request, send the reply to ITR. So it's at least we have 3 ways to do this. But if we want to reduce the time that looking up the mapping, then when you register a certain mapping, we can set the proxy bit as a true. In that case, if the ITR requests a certain mapping, then the mapping system will immediately reply that by looking up its storage. So it's a bit faster. So there are a set of open source projects that are available for Lisp, and for data plane we have 3 types of like open source. One is Open Lisp, and this is based on FreeBSD, and another one is Lisp Mob, and this can be run on top of Linux and Android and OpenWRT. So we can flash a firmware in existing like Cisco devices, and you can make it work in existing like AP. And another one is Open vSwitch, and Open vSwitch partially support this Lisp protocol. And for control plane, there are only 2 types of open source are available. One is Open Lisp, and it also runs on top of FreeBSD. Another one is Open Daylight. So Open Daylight started to support Lisp in 2013. So they had some kind of working like the control plane for that. So this is my proposal for.
Going back, there's one big missing piece, right? Which is hardware, like white box hardware switches. So what? Yeah. Sure.
Okay. So there are lots of hardware which also support Lisp, and most of them are from Cisco actually, and also include some vendors.
So what I'm suggesting is that the missing piece seems to be white box hardware. Open source implementation runs on white box.
Oh, okay.
Because that's clearly where
that's
what we're interested in doing, right?
Right. Yeah, I agree. Yeah, I think some
until that's there, you know, you have 2 really unappealing, alternatives. You know, one is, oh, well, you're not going to use hardware, and you're just going to deploy this at the edge. In that case, it's no different than any other tunneling protocol, and there's no value. And 2 is that you buy stuff from Cisco, and you certainly wouldn't want to do that. So it seems to me that's kind of a non-starter for those reasons.
Okay, I see. But I saw that some of guys they try to run this on top of just Linux box. What they have.
Yeah, but that's basically running servers.
There's 2 parts to this, right? One is Lisp is a data plane encapsulation technology,
yes.
And for that, I mean, there's a ton of other stuff, and supporting it is not terribly difficult. You probably need OpenFlow extensions to configure it over Open vSwitch, but I think not terribly difficult. Then the other part is this distributed and reactive control plane and control plane messaging and handshake, which you can completely obviate in an SDN environment. You can proactively have these routes pushed up. You can have the control plane or an application on the control plane proactively push this stuff to devices. And the handshake piece seems to be irrelevant largely in an SDN.
And then if you have, if you have a metro network that is like MPLS, once again, Lisp adds no value because, we have cheap white box MPLS with open source, right? And, so Lisp doesn't add anything to the party, so that's sort of another reason not to. Another reason it doesn't. It's not something that we really want to think about. But yeah, I mean, Brian's exactly right that you have to you probably want to think about, is there a really compelling reason to do this, and and what's the value of it?
Like to implement this control plane for.
I mean, you can do it, right?
Yeah.
I mean, there's nothing stopping you from doing it.
Yeah.
Go ahead and make it out, do it. But, but is there any value to it? Are you making life? If you have a big Lisp deployment already that you have to interoperate with, then it has a huge value for you. But if you don't, I don't see that.
Actually, there is a Lisp beta network site, and there are lots of Lisp deploy sites available, and yeah.
Yeah, but I think Brian's point is well taken, which is that if we have SDN, why would we need or not Lisp? And the answer is probably.
I mean, one case is if you had a big piece of legacy network that's already talking Lisp, you could use Lisp for doing like the virtual to physical mapping discovery.
Yes.
The SDN controller can talk to the legacy network, figure out what it is, and if you don't have OpenFlow or whatever else at the edge, or that edge for virtual network mapping discovery, you could potentially use the Lisp control protocol to do it. But it seems like within the SDN, you actually want to do a lot of this stuff proactively, or at least independent of the distributed Lisp protocol.
Absolutely.
Okay.
Yeah, yes. I mean, using SDN to control Lisp switches maybe is easy. Just as you can sort of use MPLS sort of. But I don't know. That's sort of. We'll see, I guess.
Okay. Should I go forward or?
Yeah.
Okay.
Yeah, sure.
So this is the proposed Lisp control plane for ONOS, and I think I just follow the same architecture of existing OpenFlow implementation. So it has a set of layers, application layer manager and provider, and in the manager I would like to implement the map server and the map resolver, and because it has different roles, and also for southbound. Somehow I need to implement its own controller. It's exactly almost the same like OpenFlow controller and OpenFlow device provider. So the different part is in this subsystem you use our not like the in OpenFlow system we are using PID. And there's no encapsulation and the decapsulation protocol libraries are available for Lisp, like OpenFlowJ is available for OpenFlow subsystem decoding and encoding purpose. So I would like to implement that library as well, encapsulate and decapsulate the Lisp a set of Lisp type of messages. So for this, I would like to also follow the same design pattern that OpenFlowJ has been implemented. So there's a read from method in a Lisp message reader and write to the method that we define for this message writer. So each of the concrete class should extend. It should implement the existing interface and also need to implement internal Lisp message reader and writer so that it can serialize and deserialize the Lisp messages. So this is some use cases I found if this implementation has been done. First one is a VM migration across different data centers without changing the IP address. So with the help of Lisp, we can just we can move VM from data center 1 to data center 2 without changing its VM's IP address. So in this case, we just need to tell the mapping system that the location of VM just has been changed. So it is a matter of changing the mapping information of individual XDR. And another scenario would be if there is a sensitive disaster occurred for a certain data center, then you can move all the resources to the disaster recovery data center, and this can be easily realized just by changing the mapping information in essential. The assumption here is we always synchronize all the data between data center 2 and the data center, the recovery data center. And another use case would be IPv4 v6 interoperability. So assume that we have a set of IPv4 network or v6 network, and no matter what kind of IP scheme it use, since the XTR can always encapsulate it to the corresponding IP address scheme, so that we do not need to care about what kind of IP address that you use in destination, and so on. And another, like this case, can be horizontal and vertical handover in mobile devices. Assume that one device is connected to the LTE network, like base station, and so this device will get assigned one IP address, like 10.0.0.2, and it also has its internal IP address called 1.1.1.2. And if it want to move to the Wi-Fi network without changing its IP address, it just need to move it to here, and also at the same time it send the solicit MAC request to the control plane to announce all the XTR that its location has been changed. And also, since it's a tunneling protocol, so this also can be used for the network virtualization purposes, and so on.
I have a question.
Okay.
Does Lisp is it only for IPv4?
No, it support IPv6 and IPv4.
So what about in IPv6 case, we have prefix that maintain their locator. So if we just have only IPv6, don't think we have no reason to use Lisp. I mean, without Lisp, we can manage mobility.
Can't you embed both identifiers in your IPv6? I don't remember how Lisp works, but I seem to recall that for IPv6 you can put the the location, or sorry, you can put the endpoint identifier in the IPv6 address, or something like that.
I think there are extension headers that allow you to do like mobile IP stuff. So it's the same kind of scheme, right? We have a location and identifier that is separate.
Yeah.
So it basically, I think they'll do the same thing. I think the answer is sort of, if you have IPv6, you probably don't need this, basically. Well, I mean, it depends.
Yeah, but definitely support both like encryption, like IPv4 in IPv6 and IPv6 IPv4, so both encryption can be supported.
Looks like when you think about just IPv6 network, all devices are
IPv6.
Okay. Then I think we can manage mobility without using Lisp.
Yeah. So with the existing like LTE network, it has all its IP mobility, so definitely you can just make use of that one too.
Yeah, so they're sort of the same thing. I mean, like, legacy, mobile IP sort of works the same. I mean, it's all sort of, at the end of the day, it's sort of tunneling. I mean, the thing about Lisp is like if you're living in a fully Lisp world, then it's like pointer indirection. So it's sort of nice that, okay, great, we have this separate location identifier. But then, at that point, if everything's a Lisp world, well, Lisp's claim to fame is it uses a legacy IP fabric at the core, right? So now you're saying, okay, well, if you have so it's this weird thing where I just don't. I mean, Lisp always puzzles me. Like David Ward gave this lecture about it, which totally baffled me as well. I just couldn't see the point. Where if it's just at the edge, then you don't need it, and if it's at the core, you don't need it. So it's Lisp only. It seems like its use case is very strange, where we have some number of devices in the core and some number of devices at the edge. But it's a really strange. It's a really hard sell. And so in these motivation slides that you've given, like, it's like, here's another kind of different legacy way to do some of the things that SDN already does. And I'm like, okay.
So I guess my concern or caution, sort of orthogonally, is I don't think we want to build, or we need to be careful not to build another vertically integrated stack just for the Lisp support. So something that we need to think about here is how does Lisp fit into other abstractions that are network and SDN centric. And if you want to use Lisp at the edge to do handoff or rewriting packets before they're handed off to a legacy piece or a non-SDN controlled piece of the network, that's perfectly fine. But I mean, we need to find ways to say, okay, these mappings that are coming in from Lisp, those need to talk with the network virtualization subsystem. Or they need to talk with the flow or host location or device location subsystems. And rather than, yes, you'll need to build a manager and you'll need to build the route server or whatever it's called. down at the protocol level or provider level. But the abstractions that this needs to expose up to ONOS should be interoperable with other tunneling technologies and other network virtualization technologies.
Okay.
Yeah. So, Brian Thomas, I think you nailed it as far as the design. Yeah, there's really no value. It's really the wrong approach to build this vertically integrated, this vertical slice in ONOS where we've added the Lisp control plane in, and Lisp applications talk to the Lisp control plane, which talks to the Lisp data plane. There's no value in that, right? You might as well just have a ONOS running here and Lisp running there, right? So it only makes sense to add basically, you sort of really want to think about your use cases. What's the real value here? Why on earth would anybody ever want to use this? And if you can answer that question, hopefully that'll clarify whether this is worth doing, and also how you want to do it. Is it as as Brian says, where we have this legacy Lisp network, or we have legacy endpoints that we want to stitch together to an ONOS network and make it all work seamlessly. Maybe that's it. I don't know. That seems kind of a far-fetched use case, but that might make sense. But you have to think about it, and yeah, I think very much you can certainly build this Lisp southbound protocol, have ONOS talk to Lisp devices, send information to them, and get information from them. But the goal at the end of the day is to enable ONOS applications and enable an ONOS-controlled network. And the question is, what value does this Lisp southbound, add to the party, and most importantly, how does it fit in with the existing ONOS abstractions? That's a really important question to answer.
Okay, I will think about that.
The other thing to consider is that in the SDN, you may not be using Lisp as your encapsulation technology. You may be putting stuff into MPLS packets, you may be putting stuff into whatever, VXLAN, into VLAN, something else. And so something we really need to consider is whether Lisp is going to be used in the core, or in places where Lisp is not being used in the core, how we do translation, and at what points we do translation from the Fabric encapsulation technology to the Lisp encapsulation technology, because it's unlikely we're going to use Lisp in the core, or in the SDN Fabric.
I think that's a really important thing. If you look at the way we deal with BGP, we don't run iBGP. The way we deal with OSPF, we don't run OSPF. We don't run all these legacy distributed protocols in the SDN core, because that just makes no sense, right? You have two conflicting control planes, basically two parallel control planes that, it's really the wrong way to do it. If you really want to run multiple control planes in your core, what you should probably do is virtualize your network and have one slice controlled by SDN and another slice controlled by your legacy technology.
Yeah, sure. So definitely, I've heard that we're going to support a virtual network on top of ONOS, and at that point probably you can run multiple types of network on top of that, right? So the underlying is SDN, but on top of that there will be multiple types of network would be there. So one thing is, we can run multiple the Lisp protocol there, also maybe OpenFlow or some other protocol. So to do to provide such a capability, somehow we can run multiple types of network.
Yeah, but at the end of the day, you sort of want to try to globally optimize your system, right?
Yeah.
And so just adding a legacy protocol into your SDN because you can is maybe an interesting research exercise, but is not necessarily producing a globally optimized design. You want to think about, what's the problem you're trying to solve, and what's the best way to solve it, and how can you optimize it by removing all the things that you don't absolutely need, and trying to minimize your resource usage and improve your efficiency. And rather than there's this problem, right? With encapsulation protocols are great. They're sort of additional layers of indirection. They solve all problems except for the problem of having too many layers of indirection. In the case of encapsulation, the problem is your packets get really long because they have all these headers and they get fragmented, and your MCU gets big, and all these nasty problems.
Yeah.
So considering that we already have the capability of redirecting packets without encapsulating them, whenever you add an encapsulation protocol, you sort of have to justify it.
Okay.
Yeah, for me, definitely the issue is the vertically
the vertical stack, the software stack in ONOS that's dedicated just for the purpose.
Yeah,
of
that's
it's the introduction of the
important.
new abstractions, like Brian said. It's, especially when they may be at odds with the existing ones, it's a problem. Whether or not the merit for the yet another sort of encapsulation protocol on South, I mean that's a separate discussion. For me, software-wise, it's the sort of separate.
Yeah. As far as the system design, that's well, it's pretty clear you don't want to do that, right? Like that should be clear that's the wrong thing.
I mean, it forces, in my view, it would force applications into this sort of thinking, and it's very single purpose, I guess. I don't know how to say that.
The whole thing about ONOS is it provides abstractions, so you don't have to worry.
Your applications are not portable, right?
What?
Your applications.
Yeah, please, no, exactly.
So the thing is, you can have an application
that does
at the app layer that does the management of the distributed pieces, the distributed protocol pieces of Lisp.
Yes.
And that can be an application that should be abstracted away from the core.
Yes.
It knows how to talk to the routers and whatever.
Mm-hmm.
Then you can also have a provider that's capable of talking to these Lisp devices at the edge.
Yeah.
And you can also have
Sure.
the Lisp data plane piece as extensions in OpenFlow or P4 or whatever. So I think sort of separate these things up and figure out where and how it makes sense to use core abstractions, and it's not going to be the Lisp service that has a Lisp manager and a Lisp southbound and a Lisp app that runs on top of it that consumes Lisp the service.
I mean, the thing is, such an entity can exist internally inside the app, but application. This is not something that should be exposed to applications, unless it's exposed through other more familiar or more general purpose constructs.
Yeah. I think I agree completely with that. But that you don't want to implement it in the core, but having the southbound protocol that can speak Lisp is fine. Having a driver for it or provider for it, and then having an application that implements the Lisp specific knowledge, and it's a sensible approach if you want.
Okay.
Although once again, I would suggest that before you embark on this lengthy effort, you should have a really compelling reason to do so, and think about, are there other ways you could do it that might provide the same value with less work?
Okay.
In a more efficient way. But if you have to buck Lisp, like that's your requirement, like, I have this legacy Lisp network, then you want to think about, well, how can ONOS interoperate? How can I connect? How can I stitch an ONOS network to this Lisp network the same way we talk to BGP, OSCAP, or whatever?
Yeah.
In the way that is most efficient and effective, and also but allows your ONOS applications to just continue working as usual without having to have specific knowledge of these other technologies.
Okay.
And using the same ONOS abstractions that we've been working on that hopefully are good abstractions that will get better over time.
Okay, sure. Yeah, I will take a look at some of the Alstom protocol to how to make the things like cover the existing system.
Well, like I said, Lisp always baffles me. I don't know. It's yet another indirection and tunneling protocol.
But it seems like
has some adoption, but it's this good.
Seems like lots of European universities they kind of spend lots of money on do a lot of investigation on this protocol and deploy a lot of sites and so on. So
The thing I don't like about it is sort of what I don't like about mobile IP, which is that its claim to fame is that it uses an unmodified IP core, but that means that whenever you have mobility, you end up traversing your core twice because the anchor point came, which is an irritating problem.
Yeah.
And
In this case, the anchor point can move though. You should update a mapping.
Well, it can only move if the guy you're talking to is attached to a Lisp router.
True. Yeah.
It's like a mobile IP. If the guy knows about mobile IP.
Yeah, then you're fine.
Then you're But basically, everything has its claim to fame is it's interoperable with the legacy internet without changing the endpoints or the routers, right? But for any legacy component that's talking to you, you have this double traversal problem. So it's kind of nasty.
You hairpin into an anchor point.
Yeah.
So were you thinking about working on this? So because you're heading back to Korea, right?
Yes,
so
yes.
you were thinking about this as sort of as an external
So
extra project, or?
yeah. So I think this project, if it designed well, I think it's kind of autonomous like project. Like it does work with a lot of interaction with the like online. So I think I can just manage it by myself. And also, it would be welcome that just assign me some tasks so that I can work on that. Yeah.
Didn't you have a whole other list of projects that you were thinking about? Like, I can't remember. Didn't you have presented a whole other list of projects you were thinking about? Okay,
No. It's not on yet. So I just.
Oh, you're just this one.
Yeah. Yes. Because some guys have said why ONOS has to release protocol and some there are some people pass just. I think why not just approve one, because we have lots of legacy protocols.
Yeah, but there's something to think about, which is that if having ONOS, I mean, certainly we've given people this capability of writing drivers to speak any protocol. But with great power comes great responsibility. I think we should discourage the proliferation of southbound protocols, and certainly, I think it's okay to have them, but they don't. From my perspective, they're about looking backwards to the past and not looking forward to the future. And so, just think about that.
Yeah.
I think of working back at Arista where customers would say, "I need Cisco protocol X because Cisco tells us we need it." So we're always chasing feature parity with Cisco, and I don't want to be chasing feature. I don't want ONOS to be chasing feature parity with Cisco because Cisco has protocol X, therefore ONOS needs protocol X.
Or ODL, right?
Or ODL for that matter. I don't want to feature chase anybody. I want to think about global system optimization and what's the right way to do things.
Sure.
A small set of things.
Yeah, the thing is, so we have a lot of partners who are interested in this for whatever reason, right? And some of the reasons maybe because they're vendors who sell equipment.
Like the RFC still.
And this is.
That's what I'm suspicious of vendors. That's why we didn't invite them to collaborate with us at the beginning, because vendors have business interests in legacy protocols that are antithetical to our goals with ONOS.
Sure. So the thing is, so because of this sort of opposing tension, the idea here is to let people, let contributors to introduce these things. Very much like Huawei did for switch protocols. Even though they're not necessarily core to the mission of ONOS, as long as they just exist and they fit well, reasonably well within that, it means that they don't detract from the core mission or the structure.
I think that's the key.
It's okay.
That's the key, is to make sure it doesn't detract from the core design and functionality and performance of the system and usability.
Yeah. And so kind of turning it back to the architectural bit for the software piece for the software stack. Structurally, clearly, there's nothing wrong with that stack. It's just what we need to make sure that I guess what I don't know how to point, but clearly you're gonna have something southbound. You're gonna have something to maintain state, right? Which is this and the stores.
Yes.
The question is what's going to be exposed externally. And the idea here, I would suggest that we inspect, whether you have these services, they really ought to be only internal. And to external applications, we should expose this functionality as in terms of maybe transparency of location. Okay. I mean, if this provides transparency of location, right?
Yes.
So there's really no service to be programmed. It's kind of like the VCR code that sets itself. There's no buttons on it.
Yeah, we already have like connectivity intents, which are like location oblivious routing, right?
Exactly, and so feed this, like Brian suggested, feed it through the existing abstractions or existing mechanisms.
Okay.
Or provide sort of an implicit service, with which it just presents a service on a network, but applications don't need to interact with it directly; they just indirectly benefit from it. Okay. And if it's enclosed like that, then it has values in those environments. But I want to make sure that we don't necessarily sort of provide such a single, very very highly specific purpose API. I'm not sure whether that would add any value, because I mean any applications you're going to come up with that you build on top of it are only going to operate on this environment. They're protocol specific.
Yeah. Okay. I see the point. Okay.
Yeah, I think we need to think about the useful use case.
Mm-hmm.
That want to achieve by using Lisp in mobile network. We really want to, this kind of capturation mechanism is the one we really want to get rid of. So now we are thinking we're using IPv6 to support mobility with encapsulation. So if we try to implement Lisp, we really think about the useful use case if we really use it or not.
Okay. So better use cases would be good to.
I cannot think of
the better use cases. Okay.
All right. Well,
Okay.
Any other suggestions, questions? If not, then I think we can call it a day. Thank you very much, Jen, for preparing for this.
Thank you. Lots of comments.
Bye-bye, everybody.